Okay. So technically, inks contain different colored substances called dyes. By the way, guys, this is March 2025, variant 62 IGCSE paper with a code of 0620. All right. So ink contain different color substances called dyes. A student used chromatography to investigate the color dyes contained in 6 different inks. When we do chromatography, we normally use 2 different set of phases. The first one is called mobile phase, and the second one is called stationary phase. This stationary phase could be a chromatography paper, also called filter paper. It is a non-moving phase. This is a mobile phase. It could be any solvent like water or ethanol, and it is a moving phase. All right. So chromatography always takes place between these 2 phases. Always. That's the core principle of chromatography. Anyhow, let's talk about this. Student drew a baseline on the sheet of the chromatography paper. That baseline is also called a reference line. And in class, I've instructed and I taught you that whenever you mark the baseline or a reference line, we need to use pencil for that. And why specifically pencil? Because pencil mark is not soluble in the solvent. Also, this mark cannot interfere with the sample or the dyes of the inks. All right. The student then placed a spot of each ink on the chromatography paper and set up the apparatus as shown in figure 1.1. The student made 2 errors. अच्छा जी देखें, पहला एरर तो ये हो सकता था कि लिड नहीं होती, बट एग्जामिनर ने लिड लगा दी है. इसका मतलब दिस लिड इज यूज्ड to prevent the evaporation of water. That's a function of lid. Second chromatography paper is fine. First is ये जो baseline है, usually on that baseline we need to mark the sample spots. और यहाँ पर जो sample spots हैं वो below the baseline draw कर दिए गए हैं, which is wrong. Okay, so first error is sample spots can be marked on the baseline but the student marked them below that reference line. Second is basically this chromatography paper needs to be dipped slightly in this solvent or in this mobile phase or in this water. But आप technically देखें ये it is not dipped properly in the solvent. It is not dipped properly in the mobile phase, which means capillary action cannot take place, which means movement of solvent cannot take place, which means movement of mobile phase cannot take place. So that's an error. Chromatography paper is not dipped properly in the solvent, that is water, and that is going to be your mobile phase. State the name of the equipment used to draw a baseline on the chromatography paper. मैंने कहा आपको pencil, sharp pencil. Okay. Because it is insoluble in water and also cannot interfere with the sample spots. Okay. Now the next is the student corrects the error and then carries out chromatography. The chromatogram in figure 1.2 shows the student results. Okay, ये results आ गए आपके पास. Identify an ink which could contain only one colored eye. So whenever we have one colored eye, इसका मतलब has to be only one spot. So आप नोट करें, इसमें मल्टीपल स्पॉट्स है तो ये नहीं हो सकता, इसमें भी टू स्पॉट्स हैं ये भी नहीं हो सकता, इसमें भी टू स्पॉट्स हैं ये भी नहीं है, इसमें भी टू स्पॉट्स हैं ये भी नहीं है. So this could be blue ink or yellow ink because both of them have only one spot, right? So the answer could be yellow ink or blue ink. Deduce which ink could be mixed with the black ink to make the blue ink to make the black ink. So black ink बनाना चाहते हैं हम, उसको बनाने के लिए पर्पल भी है, ब्लू भी है, ग्रीन भी है. ब्लैक इंक बनाना चाहते हैं, पर्पल भी है, ऑरेंज भी है. ब्लैक इंक बनाना चाहते हैं, उसमें ग्रीन भी है, ऑरेंज भी है, येलो भी है. सो आई बिलीव ब्लू के साथ अगर आप ऑरेंज मिक्स कर दें सो इट विल गिव यू अ ब्लैक कलर प्रॉपर. ठीक है, बाकी कोई और ब्लैक कलर नहीं देता. सो मिक्सचर ऑफ ऑरेंज एंड ब्लू गिव्स यू ब्लैक. Because mixture of blue and orange gives black. Deduce the color of one dye that is contained in all three of the orange, green, and black. Orange, green, and black. This is black. This is orange. This is green. तो वो सिर्फ और सिर्फ येलो डाई है जो कि इन तीनों के अंदर मौजूद है, राइट? Let's move on to the next question. A student investigates the temperature change. Temperature change is basically represented by delta T, and delta T is always final temperature minus initial temperature. Final temperature is represented by T2 and initial temperature is represented by T1. When aqueous copper sulfate reacts separately with two different metals, zinc and iron, obviously zinc is more reactive and iron is less reactive. So first of all, when zinc reacts with copper sulfate, it will turn to zinc sulfate and copper. And when iron is treated with copper sulfate, it will turn to iron 2 sulfate, which is a green color, and copper. Okay. So both of them are redox reaction, also called displacement reaction. Use 50 cm cube measuring cylinder. Let me draw the measuring cylinder here. Okay. Let me draw the measuring cylinder here. Okay. And pour 30 cm cube of aqueous copper 2 sulfate into 100 cm cube of beaker. Okay. So I'm gonna place copper sulfate solution into this beaker. 30 cm cube. Copper sulfate solution. Use a thermometer to measure the temperature of the content of the beaker. That is going to be the initial temperature. So place thermometer in the solution. And as a result, you will get the initial temperature before experiment. Okay. This is the temperature of the time at 0 second. That means it is the initial temperature. Add 3 grams of zinc powder to the beaker. So I'm adding 3 grams of zinc. And at the same time, you need to start the stopwatch. So stopwatch is used to measure the time or to note down the time. Using a thermometer, continuously stir. Why are we stirring the mixture? Stirring the mixture is basically for uniform distribution of heat. Measure the temperature of the mixture every 30 seconds for 210 seconds. Yani I need to stop the reaction at 210 seconds. Empty and rinse the beaker with distilled water. In experiment 2, repeat the experiment by using 3 grams of iron. So in the first experiment, we have used 3 grams of zinc. In the second experiment, I'm going to use 3 grams of iron. The procedure and all the information remains same. Okay. So let's see what we have. Oh my goodness. Complete table 2.1 by using the thermometer diagram and calculating the temperature changes from the temperature at 0. So ये आपका initial temperature है. इस initial temperature में से तमाम temperature जो हम यहाँ लिखेंगे उनको subtract करेंगे और फिर यहाँ पर temperature change आएंगे. So examiner ने दिए में हमें 30 के ऊपर हमारे पास, if you can see that 31, 32, 33 and this is 33.5. In this we have 38.0. जिस तरह से एग्जामिनर ने यहाँ 0.0 लिया है, exactly मैं यहाँ पर भी 0.0 लूंगा. It is 38, but I'm going to write 38.0. Okay. Then 41, 42, 41, and this one is 42. Oh no, 41, and this one is 41.5. Then we have 41, 42, 43.0, 41, 42, 43, 44.0. Then we have 41, 42, 43, and this is 43.5. Let me check again. 41, 42, and this one is 43. So it's 43.0. Last reading, this is going to be 41.0. So in experiment 1, this is the zinc. 3 gram of zinc is used. Okay. Over here, 3 gram of iron is used. So when we subtract these two values, I'm going to get 9.5. When we subtract these two values, I'm going to get 14.0, then 17.5, then 19.0, then 20.0, then 19.0 because 24 से subtract कर रहे हैं, and then 18.0. Okay. So this is for the zinc one. Let's talk about the iron thing. Iron का temperature देखिए 21, 22, 23, and this is 24.0. If I'll subtract these two values, I'll get 2.0. Okay. This is 25, 25.5. If I'll subtract, I'll get 3.5. Then in this 40, 25, 25, 26, 27, 27.0. So it's 5.0. Then 28.0, 6.0. Then 25, 26, 27, 28, and then 28.5. Then 6.5, 26, 27, 28, and this one is 29.0, 7.0, last 26, 27, 28, 29.0, then 7.0. The last two readings are same, which means reaction has been finished, right? One more thing, look at the temperature change of both the elements. Over here, we have biggest energy change as compared to this one, which means zinc is more reactive than iron. First thing. Second thing, look at this. Look at the values. These values are continuously increasing, right? And then continuously decreasing, right? So when temperature increases and then decreases, this is going to be the exothermic reaction. All right, that's what we have done in the energy changes chapter. So in the energy changes, I have given you the sketch graph during the exothermic reaction. Temperature of the reaction mixture rises till it reaches its maximum point, and then when the reaction is finished, the temperature goes down back to its original position, original state, that is at room temperature and pressure. Okay, so that indicates a reaction between copper sulfate and zinc is an exothermic reaction. Also, this shows the same thing, but zinc reaction is more exothermic than this because zinc has greater temperature change as compared to the iron one. Okay, I hope it makes sense to you. I hope you get the point. Okay, what's the difference between this data? Okay, data. All right. Graph. Complete a suitable scale on the y-axis and plot your results for experiment 1 and experiment 2 on figure 2.1. The point 00 has been plotted for you. Draw two curves to the best fit. Curve of the best fit चाहिए examiner को आपसे. Line of best fit नहीं चाहिए. The curve must start at 0, 0. Label both curves. Okay. So let me draw the values first. 9.5, 14. Let me draw the values. 9.5 and 14. 25, 30, 35, 9.5, 25, 30, 35, and then 35.5. No, at 30, 25, 30. 30 पे कितना है? 9.5. This is going to be the point. Okay. 9.5, 10. Okay. Then we have 14. We have 14, 60 के ऊपर. 55, 60, 65, 70, 75, 60. 60 पे 14. Okay. Then 90 per 17.5. 90, 9500, 90 per 17 and then 17.5. Okay. Then 120 के ऊपर 19. This is 19, 120, 5, 10, 15, 20. Okay. And then 150. So 150 पे कितना है? 20. Okay. 180 पे 19. 180 पे 19. 15, 16, 17, 18, 19. This is your 19. And 22, 10 के ऊपर. This is 210, 18. Okay. Let me check. This is 175. Oh, this has to be over 80. 180 पे 19. Oh, 175, 180. This is 19. Okay. And this is 210, 80. Okay. So let me sketch this. This sketch is already, this point is already given. याद रखिएगा कि हम हमेशा क्रॉस से रिप्रेजेंट करते हैं स्केच को ताकि वो स्कैनर में आ जाए, स्कैन हो जाए. So rises. Okay, let me check. 210. So 205, 210, 210 पे 17, 17.5 और ये 18. ओके. हाँ ठीक है। ओके, let me check the values again. Have I mistake? 17.5, 19 पे 17.5, 90 पे 17.5. That's fine. Let me check one more time. Then 120 पे 105, 110, 120 120 पे 19, fine. Then 150 पे 20. Hold on. Uh, 44 minus 24 is going to be 20. सही है. 150 is 20. Then 180. 180. 19. This is 18. This is 19. That's fine. This is fine. This is also fine. And then 210. 18. 5, 10. 18. This is 15. 16. 17. And this one is 18. Okay. I think so. This is 41. This is 42. This is 42. So if it is 42 minus 24 is going to be 18. So that's right. चलिए ठीक है, अब दूसरे का भी देख लेते हैं. 24 के ऊपर 2.0, 10, 15, 20. 24 के ऊपर 2.0. Then hold on. 30, 25, 30, 2.0. Then 60. 60. At 60, we have 3.5. This is 3.5. 60 के बाद 90, 75, 80, 85, 90, 90. 90 पे 5. 120 पे 6. This is 6. फिर 150 पे 6.5. 6.5. फिर 180 पे 7. This is 7. And then 210 per 7. Okay. Okay, that's this. So this is your experiment 1. And this is your experiment 2 because we need to label that. Part C, extrapolate the curve for experiment 1 after 240 seconds and reduce the temperature change. Okay, तो मैं इसको extrapolate कर देता हूँ 240 seconds तक. 240 seconds, 240 seconds, 240 seconds ये हैं. सही है, तो हम इसको extrapolate कर देते हैं 240 seconds तक. Okay. Let me check. Just 30, 35, 40, 40. Okay, till this point. Now it's fine. Oh God. Temperature change. So मैं क्या करूंगा, मैं यहां से temperature change देखता हूं. It is going to be 14.5 degrees Celsius. State which experiment 1 or 2 is more exothermic. Explain your answer. Experiment 1 is more exothermic. Explanation: because in experiment 1, zinc and copper sulfate shows large temperature change than iron in experiment 2. Predict the temperature of the solution in experiment 1 after 3 hours. After 3 hours, reaction reaches to its normal room temperature, and at room temperature, it was 24 degrees Celsius because time was 0, which means that's the room temperature. So I'm going to write 24.0 degrees Celsius. Explain why using a copper container instead of a beaker would not be the improvement in this investigation. Would not. Because copper has a good thermal conductivity. So heat may loss occur during the experiment. Describe 2 changes in the apparatus that will improve the result of this investigation. For each change, explain why it will improve the result. Obviously, आप नोट करें, हमने जो एक्सपेरिमेंट परफॉर्म किया था वो बीकर में था. बीकर टॉप से खुला हुआ था, तो यहाँ से तो हीट लॉस हो जाएगा और यहाँ से भी हीट लॉस होगा. So to prevent heat loss, use cover lid and insulation. Okay, that's the first one. Use coverlet or insulation. Heat loss from the top of the beaker. Change 2. जाहिर सी बात है, मैंने यहाँ पर टेम्परेचर मेजर करने के लिए कन्वेंशनल थर्मामीटर यूज किया है। क्लास में मैंने कहा था कि आप डिजिटल थर्मामीटर यूज करें बिकॉज डिजिटल प्रोब थर्मामीटर इज मोर एक्यूरेट देन कन्वेंशनल थर्मामीटर। So use digital thermometer because digital thermometer is more accurate than conventional thermometer. Okay, that's the end of second question. Next, a student tests two substances, solution A and solid B. Solution A is aqueous chromium 3 chloride. That indicates that this compound has chromium 3 plus ions and chloride ions. So we need to test these two ions. That's so easy. Now, to the first portion solution A, the student add aqueous sodium hydroxide dropwise until it is in excess. So in dropwise, NaOH, green precipitates are formed. In excess NaOH, green precipitates are soluble to give green solution. To the second portion of solution A, student adds 1 cm cube of dilute nitric acid followed by few drops of aqueous barium nitrate. So when we add barium ions, obviously we are testing sulfate ions, and since there is no sulfate ions in that particular solution, which is why we will not get any sort of observation, so no change because no sulfate ions present in the solution. Okay, because sulfate ions absent. To the third portion of solution A, the student adds about 1 cm cube of dilute nitric acid followed by few drops of aqueous silver nitrate. Since we have chloride ions and we are adding silver nitrate, obviously we'll get white precipitates. And obviously white precipitates of silver chloride. Now test on solid B. Carry out the flame test on solid B. Red color flame, red flame shows that it must be lithium ion. According to the syllabus, lithium has a red flame color. Now, dissolve the remaining solid B in distilled water to form solution B. Divide solution B into three portions. In the first portion of solution B, add few drops of acidified aqueous potassium magnate 7. By the way, acidified potassium magnate 7, first of all, has a purple color. And second thing, it is an oxidizing agent. So if this solid has a reducing agent, then reaction might take place. Now look at the observation. Examiner has given that solution becomes pale purple. Yani purple tha, purple hi hai. So there is no change in the color of solution, which means reaction cannot take place, and that indicates no reducing agent exists. And in your syllabus, Fe2 plus ions is a reducing agent. So Fe2 plus ions absent in solid B because Fe2 plus ions is a reducing agent. It is an oxidizing agent. अगर ये होता तो obviously color changes from purple to colorless, but there is no change in color. That indicates there is no reducing agent in solid B. Indirectly, we can say there is no Fe2 plus ions exist in solid B or in solution B. Okay. Now in the next second portion of solution B, add about aqueous sodium hydroxide. Solution remains colorless. That indicates the absence of precipitates. That indicates the absence of aluminum ion, zinc ions, and calcium ions. These ions are absent. When you add NaOH in the second portion of solution B, now heat the solution B and you need to test with red litmus paper. If ammonia gas is given off from this test, obviously this red litmus paper changes into blue. Since red litmus paper remains red, which means ammonium ions absent. So we are trying to test ammonium ion in this test 4, okay? But we conclude that there will be no ammonia in this test, ammonium ions. To the third portion of solution B, add about 1 cm cube of dilute nitric acid followed by few drops of aqueous barium nitrate. So when we add barium ions and white precipitates are formed, obviously this solution B contain sulfate ions. Sulfate ions are present, okay? Which means in solid B, we have lithium and sulfate. So describe how to carry out the flame test. Flame test, okay. Make a salt solution. Containing lithium ion. Dip the glass rod in it. Place the rod in a blue Bunsen flame. Red color is observed. Identify the ion that is tested for test 4, ammonium ions. Oops. Identify the 2 ions which are in solid, lithium ion and sulfate ion. Okay, last question related to planning. We have done this planning in the class with the diagram. Metal spoons can be electroplated with silver. Describe how a metal spoon can be electroplated with silver. Include in your answer how you could determine the mass of silver electroplated on the metal spoon. You are provided with a silver nitrate solid, a metal spoon, a piece of solid silver, distilled water, and common laboratory apparatus. You may include the diagram in your answer. Okay, silver plating, that's an easy thing. This is your ammeter. This is your switch. This is your variable resistor through which you can control the current, movement of current. and that's your metal spoon. Okay. And obviously, both of them are placed in an electrolyte. So first of all, this is your battery. Negative, positive. This is your ammeter. This is your switch. This is your rheostat, which is also called variable resistor to control the current in the circuit. This is your spoon. And obviously it has to be attached with the negative terminal of the battery, which means it must be a cathode. It is attached to the positive terminal of the battery, which means it is anode, and it must be impure silver. And guys, you know, solid silver nitrate is given, so you need to dissolve it in distilled water. And when you dissolve it in distilled water, it will turn to your electrolyte, which is silver nitrate. And remember, silver nitrate has a colorless solution. So that's the diagram. Apparatus कैसे करना है काम, किस तरह से करना है? First of all, dissolve solid silver nitrate in distilled water. And then place it in the electrolytic cell. And then pour it in the electrolytic cell. Okay. Now clean both the electrodes by using sandpaper. Clean both the electrodes. And after that, measure the mass of both the electrodes through electronic balance. Technically, I'm going to use cathode. So I can measure only cathode, okay? I can only measure the mass of cathode. So measure the mass of electrode or specifically cathode before experiment by using electronic balance. Now dip both the electrodes in an electrolytic cell. Containing silver nitrate electrolyte. I need to provide constant current of 0.6 ampere for at least 20 minutes. Constant current of 0.6 ampere is provided for at least, my goodness, for at least 20 minutes. One more thing. Let's suppose the mass before experiment was 55 gram. Okay, after 20 minutes, disconnect the circuit, take out the electrodes from the electrolyte. Measure the mass of cathode by using electronic balance. Let's say mass of cathode after experiment. Let's say it's 55.5 gram. So after experiment it was 55. Initially it was 55. So mass of silver deposited at cathode would be 0.5 gram. And that is the answer examiner was looking for. Okay. Now, one more thing. Can these values be changed during the experiment? Yes, examiner can change these values. These are not the fixed values. You can change them in the paper, okay? Or you can suggest any current and any time. All right. मैंने यहाँ current को constant लिया है, time को change कर रहा हूँ. You can do that कि time fix कर दीजिए, current change करते रहिए. You can do such sort of changes in your experiment. That's the whole plan, okay? But that is the most easiest one. By the way, in this plan, you can, wash both the electrodes with the distilled water, and in order to dry them, you need a propanol solution. So that's the higher level sort of thing, which is why I didn't mention that in my plan. But मैंने आपको वैसे बता दिया है कि अगर आपको electrodes को wash करना हो तो आपने distilled water से wash करना होगा, and obviously उनका जो वाटर उनको रिमूव करने के लिए, उनको बहुत अच्छे तरीके से ड्राई करने के लिए उनको रिंस करना होगा प्रोपानॉन सॉल्यूशन से. प्रोपानॉन इज एन ऑर्गेनिक मॉलिक्यूल. ओके, आई होप इट मेक्स सेंस टू यू. वन मोर थिंग, इन electroplating, if you remember, cathode has to be the object like a spoon or ring or anything, right? Anode, impure metal, needs to be electroplated. In fact, let me change. This is the general instructions we have discussed in theory, but for this, cathode needs to be a spoon, anode is silver electrode, silver metal, you can say that, and electrolyte needs to be silver nitrate. Okay, I hope it makes sense to you. That's the end of this paper. I'm gonna start theory paper tomorrow, okay, and day after tomorrow also.